So we've discussed congruence as far as regular polygons, that a polygon is regular if all its interior angles are congruent and all of its sides are congruent. They have the same measure. But now we're going to look at congruence between two figures. So here we have a figure 12.1 down here at the bottom, and we've got triangle ABC and triangle RST. So if I were to take this triangle and flip it over, okay, then I can place one triangle exactly on top of the other so that all the points coincide. And the correspondence would be for A would correspond to R, B and S, when you flipped it over, would correspond to each other, and so would C and T. So we write this correspondence using these arrows. So we say that A corresponds to R, like I just said, B corresponds to S, and so forth. And each of these pair of vertices that correspond to each other are called corresponding vertices. So we know that if we were to flip the triangle over, that every point on the first triangle, ABC, would correspond with exactly one point on the second triangle, RST. So we call this special correspondence a one-to-one function. Okay, so we don't have one point corresponding to more than one point on the second triangle. Okay, it's all one point on the first goes to exactly one point on the second. So when we use these assignments of points to points, okay, so we get a figure and then we get its image. Okay, and these are called mappings, or sometimes they're called transformations, and we'll talk specifically about different types of transformations after we cover similarity. So if I am going to use a mapping, then we correspond the sides with each other, they correspond to each other, and we write the correspondence like this, our double arrow, and then each of the angle pairs that correspond. Now, corresponding sides, as you can see, and corresponding angles. And so we're going to use these concepts of corresponding sides and corresponding angles in the following definition. So two polygons are congruent if and only if. Okay, so that means if they're congruent, I can say this is true, and if I know these are true, I can say that this is true. So two polygons are congruent if and only if there is a mapping from one to the other such that corresponding sides are congruent and corresponding angles are congruent. Okay. So it's important that we write these congruents. This is our symbol for congruence, as we've seen otherwise in chapter 12, I think it was, but I'm not for sure. So we have triangle ABC and triangle RST. Now, I have to write these in order so that the corresponding vertices are in the same position. And then C corresponds to T. So I've got that correspondence, this correspondence, and that correspondence. Okay. It's important that you write it that way so you know if you write a congruent triangle, you have to write it in the correct, or that two triangles are congruent, you write those in the correct order. And then if you're told that two triangles are congruent, then you already know which vertices and sides correspond to which. Okay, so since they told us here triangle ABC is congruent to triangle DEF, then I know A corresponds to D, B corresponds to E, and C corresponds to F. And because those corresponding angles are congruent, okay, I know if I know what A is, I know what D is, and so forth. And then because I know that AB and DE are congruent, I can go ahead and mark those. Okay, so by saying they're congruent, then I can conclude the correspondence. So there is one side-side-side congruence property that you should have come up with in your lab that says if 3 sides of one triangle are congruent to 3 sides of the other triangle, then the 2 triangles are congruent. And I can't remember if this was part of your lab, I believe it was, or not, but if you take any triangle and you add the lengths of 2 sides, they have to be a sum or have a sum that's greater than the third side. And that has to work with any pair of triangles. So suppose I'm asked, can I make a triangle that has side lengths 2, 7, and 1? Well, if I had 7 and 2, that's greater than 1. But if I had 7 and 1, is that greater than 2? So I cannot make a triangle with those side lengths. Another property you should have come up with in your lab is the side angle side property, which says if 2 sides and the included angle of one triangle, so we have to have, and these may not be perfect, but so if I have 2 sides and the angle that's included between those sides is congruent to 2 sides and the angle between those 2 sides on another triangle, then I know that the triangles are congruent. And these are each properties that you need to memorize, but you probably already know these by SSS, SAS, and then there's another one, ASA. Okay, now for some reason this did not transform to be angles. Okay, so here's an example. It says use the SAS congruence property to determine whether the following pairs of triangles are congruent. Okay, so we have our congruent angles here marked. Okay, now here I have this side and an included angle. Here I have this side and this side, but this angle is not congruent. So these triangles cannot be congruent. In number 1, not congruent. If I had more information, I might be able to tell something else. And now you can't tell by the pictures themselves. You can only tell by exactly what you're given about the side lengths. Now, in number 2, I've got 2 sides in one triangle that correspond and are congruent. Just 2 sides in another triangle. I don't have any angles marked, but I do know something about vertical angles being congruent. So now I have this side, its included angle, and this side, and then a congruent side, the congruent included angle, and the congruent side. So this is congruent by side angle side. Okay, so we already talked about the solution here. Example F, they're not concluded because we don't know anything about the included. They're not congruent. because we don't know anything about the included angle. And in the second, the triangles are congruent because we do know that the included angles are congruent. Okay. So one other property where we have angles we have this angle A and this angle B. I don't know if they're congruent or not, so I'm just going to mark them with different things. We have the included side, the side that's between. Okay. That gives us angle side angle congruence. So if we have two sides, two angles, and those aren't very pretty, but so if I have this angle, and I happen to know that this angle and this angle are congruent to those, so they correspond, and I know that the side that's included between those angles is congruent, then I know that the two triangles are congruent. Okay, so again, let me mark angles, angles, angles. So here in number 1, okay, I have two angles that are congruent. I also have two angles that are congruent here, but I don't know anything about the side included between these. Okay, so I don't know about AK and GE. But I do know that the angles of a triangle have to add up to be 180. So if these two angles are congruent, their sum should give me something that adds up to 180, and so should this one. Now, do I know anything about included sides? So I have this angle, and its included side. I have the one with the 2 mark, the 3 mark, and its included side. So yes, using the other property I know about triangles, then I can conclude, so what I can conclude is that angle H is congruent to angle C, and that's by the triangle sum theorem, that all the angles in a triangle have to add to be 180. And now I know that the included side between the same two angles is congruent. Again, here I know that these angles are congruent because they're vertical angles, right? And I know that these have to add up to be 180, and the same have to add up to be 180, so these two will be the same. Okay, so angle, side angle, angle, side angle. Again, we can use that. We didn't actually even have to mark that congruence on the other two angles to know this is true. We just had to know this, that the vertical angles are congruent.